Let's prove the sequence a sub n equals 1 times 3 times ... 2n minus 1 over 2 times 4 times ... 2n has a limit. So in order to show that it has a limit, we're going to first talk about monotonicity. So what we're going to do is consider the ratio, the n plus first term over the nth term. And we want to show that this is either increasing or decreasing. So just by looking at the ratio, we'll find out. So the n plus first term, basically we want to go one more term after this. So that's 2n minus 1, and then the one after that will be 2n plus 1, because this one skips a term. And then on the bottom, we're going to go one more after 2n, so it'll be 2n plus 2. Okay. And so this can simplify, or actually, sorry, this is the n plus first term, and then we need to divide it by the nth term. So this is the n plus first term, this is the nth term, and then we can just simplify. So all of this will cancel, and all of this will cancel with that. So what we're left with is 2n plus 1 over 2n plus 2. And so the question is, which one is bigger? Is the top bigger or the bottom bigger? Well, 2n plus 1 versus 2n plus 2. Clearly 2n plus 2 is bigger when n is greater than 0. And when n is greater than or equal to 0. And here we're looking at a sequence, so here n has to be bigger than or equal to 1. So this is true. Therefore, the denominator is bigger than the numerator. And so this will, this means that a n plus 1 is less than a sub n. And so this means that the sequence is decreasing. So it's monotonically decreasing. So this is, yeah. So this implies that a sub n plus 1 is less than a sub n. Okay, the second step is to show that it's bounded. So clearly, we have positive values for n, because obviously it's a sequence, n is greater than or equal to 1. So you're multiplying positive numbers, and then you're dividing by positive numbers. That means that it has to be positive. So clearly, this is greater than 0. But we want to see if it's bounded above. So rewriting this, we can split this up into multiple fractions. So we'll just take the first term on the top, first term on the bottom, and then the second term, third term, etc. And then we'll stop at the last term. Each one of these is less than or equal to 1. So therefore, when I multiply the ones, that's going to be less than or equal to 1. So the sequence is bounded by 1. So since the sequence is monotonically decreasing and bounded below, by the monotone convergence theorem, the sequence must converge to a limit. Therefore, we say a sub n has a limit.